Jai Hind all. I am Samender Singh, Assistant Professor in CSC Department from AKG Ajay Kumar Garg Engineering College, Ghaziabad. In this semester, I've taught the design and analysis of algorithm. In today's session, I will discuss about what is dynamic programming, and we will solve a very known problem, that is 0 1 knapsack problem. So before discussing about what is knapsack problem, let's talk about what is dynamic problem. So dynamic programming, like, it is very much similar to divide and conquer methods. It solves problem by combining the solutions of their subproblems. Means first we need to divide the given problem in subproblems, and after that we are finding solutions of these subproblems, and in the last we will conclude by means of combining the solutions of these subproblems. So we typically apply dynamic programming to optimizations problem. What the mean of optimization problem? These are the problems where we need to find maximum or minimum results. So this is must to. For dynamic programming, we are focusing only on optimization problems. Such problems can have many possible solutions. Each solution has a value, and we will find two solutions with the optimal, that is minimum or maximum. So we will go for either minimum or maximum. So problem must be optimal in nature. We call such a solution an optimal solution to the problem as opposed to the optimal solution, since there may be several solutions that achieve the optimal value. So there must be possibilities to have more, or we can say many more solutions. So we need to find the best solution. So these are the properties how we can solve by means of dynamic programming. We developing a dynamic programming algorithm. We follow a sequence of 4 steps. So these are the must 4 steps when we are solve problem by means of dynamic programming. First step is characterize the structure of an optimal solution. So we need to find what is the problem. So we thoroughly check the real problem. Then recursively define the value of an optimal solution, and then compute the value of an optimal solution, typically in a bottom-up fashion. I already told you that we first divide the given problem into subproblems, and after dividing the problems into subproblems, we just find the solutions of each subproblem. When we find solution of each subproblem, then we merge these solutions to give the required solution. So in bottom up fashion, suppose this is a problem and we are subproblem 1, 2 and subproblem 2. So this is the solution of subproblem 1, this is a solution of subproblem 2, and this is a solution of subproblem 3. So these are the things. Now we will merge these two. So after merging, so this is a bottom up approach. First, for finding the solution of the given problem, we are going bottom to up. So this is compute the value of optimal solution, that is typically in bottom up approach. This is how we are generating the required solution. And in the last, construct an optimal solution from computed information. This is last step. So step 1 to 5 from the basis of dynamic problem solutions of the given problem. If we need only the value of an optimal solution and not the solution itself, then we can omit step 4. So step 4 is already required when we want to find the ultimate solution of the given problem. When we do perform step 4, we sometimes maintain additional information during step 3 so that we can easily construct an optimal solution. These are the 4 characteristics of dynamic programming. Now it is very important questions as far as our exam concerned. What are the basic difference between greedy approach and dynamic programming? These are looking or similar for solving any optimal case. So first, both are methods for solving optimization problem. I already give a fair idea about what is optimization problem. Then greedy algorithm are usually more efficient than dynamic programming solutions. So greedy algorithms are much more efficient. And however, often you need to use dynamic programming since optimal solutions cannot be guaranteed by a greedy algorithm. So we can say sometimes we are not sure about the solution of greedy algorithm. So use dynamic programming for solving such problems. Dynamic programming provide efficient solution for some problems for which a brute force approach would be very slow. So in a traditional brute force procedure, solutions are getting in a slower rate. So we provide efficient way by means of dynamic programming. To use dynamic programming, we need only show how that the principle of optimality applied to the problem. These are the core difference between these two famous approach of solving the given problem. Now, this is the first and very common problems that we are going to solve by means of dynamic programming. So first we need to know about what is problem, or we can say what is knapsack problem. So first, knapsack, we are using a word knapsack here. What is the meaning of knapsack? Knapsack is a bag having capacity So in the knapsack problem we have given n items 1 to n items are given having weight. Each item have its own weight, and we will first compute the maximum benefit and then determine the subset. So it's a problem where we have to include a number of items. Among the given items, the problem is to include those items that will give the maximum benefit. So this is all about the knapsack problem. To use dynamic programming, we solve a smaller problem and then use the optimal solutions of these problems to find the solution of larger ones. This is the nature of dynamic programming. So let's see how we can solve this one. So this is a structure of dynamic programming approach. Assume a subproblem in which the set of item is restricted to 1 to I, where I is less than or equal to n. So we can include number of items up to n, and the weight of knapsack is W. So this is the maximum capacity of the given knapsack. Knapsack means a bag having capacity W. So W is ranges from 0 to capital W. Capital W means summation of the weight of the given items. Let's BIW denotes the maximum benefit achieved for this problem. This is what we are finding the solution. This is the required solution. We are going to find it. Our goal is to compute the maximum benefit of the original problem, that is B and W. We solve the original problem by computing BIW For I is equal I ranges from 0 to n, and for W it is ranges from 0 to capital W. So we need to specify the solution to a larger problem in terms of a smaller ones. So there are three cases. First, we didn't have any items, means we are not including any items. In this particular case, the weight of the knapsack is 0. Since we are not including any item, so weight remains 0, and benefit is also 0. Since no item, so no benefit. This is our first case. In the second case, we have given weight of the item I exceed the weight W of the knapsack. Item cannot be included. Why we are not including items? Since the item's weight is greater than the capacity of the knapsack. So this is second case in which we cannot include those items having weight more than the capacity of our given knapsack. So this is second scenario. So in first scenario, we are not including any item, so benefit remains 0. In the second scenario, it is a case having an item of weight more than the capacity of knapsacks. In this particular case, we cannot include this kind of items into our knapsack, and this is the final possibilities through which we are including the items into our knapsack. That is, the benefit is maximum achieve either not including items, that is Bi minus 1 W, or by including items, that is Bi minus 1 W minus Wi plus Bi. So for first case, that is not including item, profit remains 0. In the second, Bi minus 1 W if Bi is greater than the capacity of knapsack. And the third case, we are taken the maximum among these two values, either the previous value, that is Bi minus 1 comma W, and Bi minus 1 W minus Wi plus Bi, where Bi is the given items benefit. So these are very complex equations. Let's see how this can solve. So as an input, we have number of items having weights. So n items there having W1, W2, Wn are the respective weights of these items, and B1, B2, Bn are the profit of each item. That is, B1 is the profit of first item, B2 is the profit of second item. In the same manner, Bn is the profit of nth item, and W will be the capacity of the knapsack. So what we are going to find? We are going to find the maximum profit by including number of items in terms of their profit. So this is what we are our output, that is B and my n comma W. So for these are the processes we are going to do. First, W 0 to W do row 0, means first row will remain 0. That means we are not including any items. In the same manner, K remains 1 to n, do row 1 to n, and BK0 elements in column is 0. It is also representing that if we are not including any item, so that means we have 0 profit in this case. And this is the third case, third scenario, that is we have a loop that is 1 to n, for W is 1 to W, do element in column, and if Wk is less than or equal to capacity of knapsack, and we will check the third scenario that we will already discuss in previous PPT. Then these are three things. This is our algorithm through which we are going to solve the 0 1 knapsack problem. So let's take a example 1. Here we have 4 items. Item 1 having weight 2 and profit 1. In the same way, we have item 2 having weight 3 and profit 2. In the same manner, we have item 3, weight 4 and profit is 5. Fourth item having weight 5 and profit 6. And this is capacity of knapsack. Let's do it in a very common way. So, our capacity of the knapsack is 8 and we have 4 items. Among these items, we have to include those items that have maximum profit, that will give maximum profit. So let's start. So as a first step, we create a matrix having row representing the profit and column representing the, this is profit and this is representing the weight of the items. So weight of the items can ranges from 0 to capacity of the knapsack. So here capacity is 8. So we have 9 row starting 0 to maximum 8. So starting 0, then 1, then 2, then 3, then 4, then 5, 6, 7 and last is 8. So these are the 8 column representing profit, representing capacity of the, these are the capacity of knapsack. Ranges from 0 to maximum capacity, that is 8. W is 8. So we are creating 8 or 9 columns in this particular problem. Now as we talk about the row, so row must be profit, or we can say number of items. Here number of items is what? How many items in this particular case? We have 4 items. So starting again 0 to 1. 0 to 4, these are the items. Again we are taking profit Pi and weight Wi of each item. Since in the first case we have 0, if we are not taking items, profit remains 0. So this is our first case in this. And then first items weight is 1, profit is 1, weight is 2. In the same way, second item weight is 3, third item weight is 4 and fourth item weight is 5. In the same way, profit of first item is 1, profit of second item is 2, profit of third item is 5 and profit of fourth item is 6. So this is, these are our initial empty matrix. So these are the things. In the first case, when we are not including elements or item in our knapsack, so weight remains 0. So no. And in the same way, profit remains 0. This is first entry that can be filled by means of this one. Now each other entry, or we can say first rows, every entry of first row we are going to fill by means of the formula that is given in the previous way. So value of I comma W will be maximum value of I minus 1 comma W, or value of I minus 1 W minus WI plus profit of this particular item. This is the formula through which we are going to fill our entries. So first, fill first entry, that is V11. Here profit is 1, or we can say item is 1 and weight is also 1. So let's fill the entries. Maximum value of these two. So maximum is what? V of I minus 1. I is 1 here. So this is 0, comma 1. 0, comma 1 is what? 0, comma 1 is 0. So this is value is 0. Or second case, let's discuss the second case, that is V I minus 1 means 0. Weight is what? 2. Weight is what? Here W is what? 1. 1 minus weight of this particular is minus 2. So 1 minus 2 is what? Minus 1. So this is not a valid entry. So it is not applicable in this particular case. So we will take 0 as this particular entry. In the same way, we can fill all the entries like this one. V12 V12 will be V1, that is 0 2 0 2 kya 0. We are taking maximum value of these two, or V0 and W is what? W is 2 minus weight of this particular thing is also 0. So this is 0 plus P of I. P of Y is 1. So this is 1. So this is 0 0 plus 1. This value is 0. 0 plus 1 is 1. So this value is 0 and this is 1. Which is maximum? Obviously 1 is maximum. So this entry will 1. In the same way, we are filling all the values like this one. So these are all entries which we are fill by means of this formula. Now we are going to find the solution. Solution is what? We need to identify those elements, those items that we are going to fill to get to finding the maximum result. After filling these matrix in the bottom up approach, so bottom up approach, we will find this entry. This is the last entry. So by showing this entry, first we need to find this entry is repeated in or lie in the previous row. 8 is there, but it is not in this row. So that means this entry comes by means of fourth items. You can say, or we can say maximum profit is achieved by including fourth element. Suppose we have x1, x2, x3 and x4. So this entry is maximum profit is 8, and this is not repeating in previous row. So we are including this respective element of this, that is fourth element. So we are including this one. After including this, maximum profit is 8 and its particular profit is what? Its profit is 6. We are including this one. So if we are including this, now subtract the respective profit of this element. So after deducting this profit, we are remaining 2. This is including. Now see third row. This entry is there. Yes, this is there. Now see this profit is repeated in previous row. Yeah, this is repeated. That means for achieving maximum profit, this element has no role. So we are rejecting this one. We are rejecting this one means 0 for this case. Now comes to this two row I'll already do. Now in the same second row we have 2. Again looking this profit into previous row, but this is not there. That means this 2 is come by including this element. That means we are including second item. After including this, we are taken the profit of this. That is 2 minus 2 is 0. So profit remains 0. Now see the 0 is in first row as well as 0 row. So that show first is also rejected. So this is our final solution. That means we are not taking first element, we are taking second element, we are not taking third element, we are taking fourth element. This is our required solution, feasible solution. Means this is the sequence of items that will give the best, or we can say maximum profit. Maximum profit is what? 8 is the maximum profit. So this is how we solve this 0-1 knapsack problem. Jai Hind all.